For each positive integer n, let yn is equal to 1 by n whole n plus 1 into n plus 2 n plus n whole to the power 1 by n. For x belongs to real number, let bracket x be the greatest integer less than or equal to x. If limit n tends to infinite yn is equal to L, then the value of bracket L is what? For solving this question, we want to transform yn into a pattern so that it would be easier for us to solve in whatever form that we want to. For that, to make a pattern out of it, first we represent the original equation, that is yn is equal to 1 by n whole n plus 1 into n plus 2 n plus n whole to the power 1 by n. So the n that is in the denominator, we want to fit it so that it becomes one term. So for that, we can write yn is equal to n plus 1 to the power n into n plus 2 n plus n divided by n to the power n whole to the power 1 by n. The first we represent first as equation number 1 and this is equation number 2. So equation number 1 and 2 are same. So we have just written it in a way so that it becomes a whole something to the power 1 by n. Then we can write it as yn is equal to n plus 1 by n into n plus 2 by n n plus n by n whole to the power 1 by n. So if we assume limit n tends to infinite yn is equal to L, then taking log on both sides, taking the log with respect to e, that is ln, on both sides, we get this becomes ln of L is equal to ln of n plus 1 by n into n plus 2 by n n plus n by n whole to the power 1 by n. So then we can use a logarithmic identity n ln x. So by that we get ln of L is equal to 1 by n ln of n plus 1 by n into n plus 2 by n n plus n by n. So we can further simplify it as using another logarithmic identity, which is, we can write it as ln L. So the identity we are going to use is, we do not want to keep it in the multiplying form. We want to form it as a summation. So we want to apply the logarithmic identity, which is ln xy is equal to ln x plus ln y. So applying that, we get ln L is equal to 1 by n whole ln n plus 1 by n plus ln n plus 2 by n plus dot 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 ln n plus n by n. So this can be written in the form of a summation as we were discussing. So it can be written as ln L is equal to 1 by n summation r is equal to 1 to r is equal to n ln n plus r by n. So to solve this kind of summation, we can transform it into a integration by using r by n as x. So 1 by n becomes dx. So the total and the limit can be found out as r is equal to 1. For r is equal to 1, r by n tends to 0 as n tends to infinite, and r is equal to n implies r by n tends to 1 for the same thing, for n tends to infinite. So the limit can be written as ln L is equal to 1 by n transforms into dx. So this is integration of x 0 to 1 ln 1 plus x dx. So now we apply the integration rule, integration by parts, to find the logarithm of 1 plus ln 1 plus x. So for that, we have to find ln L is equal to integration 0 to 1 ln of 1 plus x dx. So we take this as the first function, and so this can be written as 1 into ln of 1 plus x. So we can consider 1 as the second function, first function and second function. So the integration is integration of fg dot dx. So this can be represented as an integration by parts formula. This is equal to, so if we consider f as first function and g as second function, then this is equal to first function into integration of second function minus integration of differentiation of first into integration of second. So using that, we have ln L is equal to first function, which is ln 1 plus x, into integration of 1 dx minus integration of differentiation of first into integration of 1 dx whole integration. So this transforms as ln L is equal to ln 1 plus x, and these all have limits 0 to 1, so we cannot read it. So ln 1 plus x into x with limit 0 to 1 minus integration of 0 to 1. So the differentiation of ln 1 plus x is 1 by 1 plus x. So we write all the formulas that we have used in the right hand side. So ln 1 plus x dash is equal to 1 by 1 plus x. and the integration of 1 dx is x. This is equal to into x dot dx. So this represents ln L is equal to ln 1 plus x dot x from 0 to 1 minus. So this can be represented as 0 to 1 x plus 1 minus 1 by 1 plus x dx. So which is basically, so we can write it as ln L, which remains same, is ln 1 plus x into x, integration limit 0 to 1 minus integration of 0 to 1, 1 minus 1 by 1 plus x dx. So this is basically ln L is equal to ln 1 plus x into x 0 to 1 minus integration of 1 minus 1 by 1 plus x dx 0 to 1. So this is ln L is equal to ln 1 plus x into x 0 to 1 minus x minus ln 1 plus x whole limit 0 to 1. Now we substitute the value, and this is very simple, and we can do it as ln L is equal to, so this is ln 2 into 1 minus, this is 1 minus ln 2. So this is equal to ln 2 plus ln 2 minus 1 is equal to ln 2 into 2 minus ln 1 is equal to ln, so this is LHS ln L. So this is equal to ln 4 minus ln, so this is not actually 1, this is so this is 1, which is ln E. So this is equal to ln 4 by E. That implies L is equal to 4 by E. So E is basically, so E is actually something around 2.71 dot. So that implies L is actually 4 by 2.71 something, which is basically 1.48 something. So the bracket L is equal to 1, which is the final answer.